we'll go over some of the homework. That sounds perfect.
Yeah.
I haven't gotten them all done yet.
And then don't forget on Monday, come at 10:30 if you want extra time.
Yeah.
If you want more than the 55 minutes. And then, because we're going to review chapters 1 through 3 after, units 1 through 3 after that one. Okay, so let's take a look at this homework. I'm trying to get that open.
Oh, the review sessions next week are gonna be at our regular time, but just 1 hour,
An hour and a half,
hour and a half, so,
Yeah.
11 to 12:30 or something?
11 to 12:30 exactly.
Okay.
Let me see if I can log in. I can remember my login. Good. All right, so let's see what we got here. We've got Unit 8
Yeah, that, the first one.
and so this one is let me see if I can make them bigger.
This one, the first one, you just rewrite it in
Exponential form.
form, right?
Yeah, so this is practice rewriting things in exponential form. So 4 to the, remember, this is my base, this is my exponent, that's my answer. So 4 to the m equals 16.
Hmm.
This one's the same thing. 9 to the third equals x,
Hmm.
right? This one here, a to the x equals a to the third. What's x? Does that sort of make sense?
See the x equals x to-
A,
Yeah.
right, A is my base, x is my exponent, a to the third is my answer.
Okay. The whole thing.
So, yeah, the whole thing.
Yeah.
I want to look up, see that, the whole thing. A to the third, that's my answer. So a to the x equals a to the third, what's x?
Oh,
Yeah.
3.
3, yeah, totally.
Then you have to solve this one, right?
You do, yeah, you do have to solve, you have to figure out what x is. By seeing that a to the x equals a to the fourth, and then x has to be 4.
Right.
Does that
Okay.
sort of make sense?
Yeah, yeah.
So you are solving for x in some way. So that's kind of what all these are.
Okay.
Here, a to the x equals a to the n, x is n. Right, does that sort of make sense?
Mhm.
Okay. And then this is more of the same.
Well, this one now is like, it's
Um,
missing a, oh, it's still x? So
Right.
it's
So this is
5 to
x.
the x
Yep.
equals 5/11 to the
Yep.
11th or
Right.
something?
So
Okay.
5 to the x equals 5 to the 11th, what's x? And then what exponent is it where 5 to that exponent gives you 5 to the 11th?
So then what do you do, log?
Just right, 11, that's it, look,
Oh,
11.
oh yeah, because it's always but the next one doesn't have the 11 on
Yeah,
it, so.
2 to the what gives you 16? 2 to the what power is 16? You just gotta figure out what the exponent is.
So in these ones, it's like a guessing game.
No, well, sort of, but not really. I mean,
You're just
you can do the
plugging in.
calculator. 2 to the, try it. 2 to the third. Oh no. 2 to the fourth. Oh no. You just keep going until you.
So you're guessing, you're basically trying stuff.
Yeah.
There's no really system that actually figure that, like,
It's
straight
more
up,
like
like this
comment.
plus this is gonna give you the answer.
Right.
Okay,
You should just try numbers.
oh,
Yeah.
okay.
And then use property of logs to solve this. So if these two things are equal, right? What does x have? What does x have to be?
5.
5. Right. You can kind of. Does that make sense for folks? Find the exact value. So 2 to the what power is 1 over 16. Right, so you're dividing by, so over here you're multiplying to get to 16, right, on B. Now you're dividing by 16, so it's going to be a negative exponent.
Because you're
Dividing.
doing the reciprocal or something?
Yeah,
or-
yeah, well, because 16 is on the bottom, so it needs to be 1 over 2 to the something, right? So it's going to be 2 to the negative exponent.
Oh, 1 over 2 or something?
Well, I mean, 16 is what? 2 to the what power?
3?
So the 1 is 2,
Oh, 4
4.
to the second.
8, 16. That's how I do it. I say 2 to the 1 is 2, and then the second power multiplied by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That's how I do it.
Oh, you couldn't do 4 to the second?
It's log base. The base is 2.
Oh, see,
do you see the base?
Yeah, I see the base, but I
Yeah,
don't know
the
what
base
that
is 2.
has
So,
to do with the 16.
so 2 to the what? 2 to the what is 16? 2 to the 4th is 16.
Oh, you have to use 2.
Yeah,
Okay.
because my base is 2.
Oh, I gotcha.
Yeah.
Okay. Okay.
So 2 to the 4th is 16, but I don't want 16. I want to divide by 16.
Is it a negative?
So it's negative. 2 to the negative 4th. It means you divide by.
So anytime you have a fraction, it's a negative?
Yeah.
Yeah, because the exponent rule, I think.
So I get mixed up with these signs still, you know, with the, when
I
it's
understand
negative
that.
with
I
the
understand
fractions, yeah.
But and everybody does.
Yeah.
It's not unusual, right? But you do have to remember that 1 over 9. Okay, so 3 to the second is 9. 3 to the negative 2 is 1 over 9.
It's 1 over.
We've done this many
Oh.
times.
Okay,
Because
so
of
it's
the
just the opposite.
3 to the
Exponent rule.
second is 1 times 3 twice, right? 2 3s.
Yeah,
3 to the 1 is 1 times 3, 1 3.
yeah.
3 to the 0 is 1 times no 3's at all. 3 to the negative 1 is 1, not, here I was multiplying by 3, and instead it's going to be divided. Negative means do the opposite, right? So it's going to be divided by 3.
Did everyone get to sign in?
3 to the negative 2, thank you folks, is 1 over 3 times 3. 1 over on the bottom,
Yeah,
right?
this is just where, I've never understood this. I know you showed it like 8 times, but
Yeah.
I never really understood that, when you get down to these negatives. And why it's
Well,
3 times
okay,
3.
so to the second power means you multiply by 2 3's,
Oh,
right? 3 to the 1 means you take 1 and you multiply by 1 3.
oh,
So
that's fine, okay.
this tells you how many 3's you're multiplying by.
Okay,
You multiply by no 3's. And here you undo multiplying by a 3. How do you undo multiplying by 3? Divide by 3.
okay.
Here you undo multiplying by 2 3's. You divide by 2 3's.
Oh, okay, and then the next one, negative 3, would be 1 over 3 times 3 times 3.
Yeah,
Okay.
exactly. So, yeah, so there's that one. Write the equation in exponential form. So that's just writing t to the, my base to the exponent equals the answer. And then this is the same thing. Write it in log form. So now you have what's my base, log, and then you have your base, and then you have your x equals your exponent, and then you have your, this is your answer, right? So log, remember it goes log, and then you have your base, and then you have your answer equals the exponent.
So this one,
So-
we what, log?
You gotta write it in this form. Right, you gotta write this in this form.
So what would be the answer to 8? Log 7
Uh-huh.
something?
Log sub 7, the base is 7, so it's the tiny 7 below,
Oh, okay.
and then the answer goes right
Oh,
Here.
next to it, yeah.
right there,
So W
and then equals
equals T.
t, equals the
Oh, okay.
exponent.
All right.
And then here, all you're doing is showing what you know which these pieces are. You know which one's the base, right? This is the base.
Yeah.
You know which one's the answer, right? This is the answer. You know which one's the exponent, right? This is the exponent. So you just kind of, it's proving you know where those pieces go. This is the same thing, only with fractions instead sometimes. This is more the same thing. And then this is that log property. So 3 to the what equals 3 to the what equals c to the 5th. Oh, no. You're just rewriting, you're using the power property. So
Yeah.
if you look at this one, it's just reminding you that if you have a log and you have an exponent up top, you can drop that exponent in front. Right, so this is going to be, here I'll show you the answer. Right, 5 gets dropped in front.
Oh, yeah.
So that's the answer, we don't actually
That's it.
solve it?
Nope, that's the
Okay.
answer. It's just using it, it's called the power property. And if you kind of work through it, it eventually gives you the answer, doesn't it?
Mhm.
So then once you do that, then you'll see, oh, that's not what they want us to do.
Yeah, that's what I do
And
sometimes.
there's 2 of those. That's it.
Oh, that's it? Okay.
Yeah, that's it.
I don't know why I had such a tough time with that when I went through it. I mean, I got through it, but it just, Oh,
Did you do it before last class?
No, I just did it like a couple days ago, but
No.
I think I understand it more maybe now because I did it.
Right. And then this one is, okay, so you gotta solve for x. So here, first you gotta get the log by itself, right? You gotta get rid of the 7/2. How do you get rid of 7/2?
You multiply by 2 sevens.
Yeah, multiply by its reciprocal. So multiply both sides by the reciprocal, and then you'll see, you'll get something that will be like a number over here, and so 4 to that number equals the answer, right? That's kind of, and then the same thing with this, this is another one of those. But except for that, it's gonna be a fraction. Now you have 2 to a fraction, 2 to the 3/6, or 2 to the 3/7 or something like that, right? So you have to raise 2 to a fraction in your calculator to get the answer, x. Here, 4 to the 3rd equals this number, and then you have to solve, you have to figure out what 4 to the 3rd is and then solve.
So on that one, you remove the x, you move the x plus 2 to the outside and then you, because I,
No, stop, stop.
yeah,
Okay, so here, this is my base, you're just gonna rewrite it. Anytime you have a log, try rewriting it if you can as a exponential. 4 is my base, what's my exponent?
here,
What's my exponent here, folks?
3.
Ryan? What's my exponent?
I'm not sure.
The base is 4. David?
The log?
So when you have a log, when you write it as an exponent, you have a base, and then your exponent is the thing that it equals on this side. So so the previous one we had, four is my base. What's my exponent?
M,
M. What's my answer?
16.
16. So 4 to the m equals 16. Does that make sense for folks? Every time you have an exponent, you got to do that. You've got to sort that through. Okay. Is your dog okay?
Yeah.
All right. So 4 to the m equals 16. You need to know that. This is your base. This is your exponent. That's what it equals. And I call it the answer.
And you said when the subscript is missing, that means it's 10?
It's 10.
The base is 10?
Yes.
If the subscript's missing?
Yep.
Okay.
Due today.
What was that?
Yeah, there's 2 homeworks due tonight.
What was that?
He asked if it was due today.
Oh.
No, this is next week.
Because.
One of them is due tonight, and one's due on Sunday. This one's due Sunday.
Oh.
The other one we looked at is due tonight.
There's 2 due tonight.
There's 2 due tonight?
Well, it says due on the 10th. 2.
That's the unit 7 still. I think the 8s are due
Oh, did I
next
bump
week
you at 7 back?
or something.
Not sure.
I don't know.
Yeah, unit.
Yeah, unit 7 and unit 8.
Oh.
Those are the graphing ones I was asking about.
So we should take this one off. Okay, so this one, some of them are increasing, right? And some of them are decreasing. So to figure out, this one's decreasing.
So that's the 0.8.
Yeah,
That's
so
none
its
of the
growth
back,
factor
yeah.
is less than 1. This one's increasing the most. Does that make sense? So it should have the highest growth factor.
Yeah, like that.
And then evaluate each of the function. So it's put in different numbers for x and evaluate it. So 0.16 raised to the negative 1/3 times 27. This is just giving you some practice
Mm-hmm.
evaluating some things. I want people to practice out a little bit so they got used to it. This, I didn't want to have you do both of them.
Same thing,
That is probably extra. So I can take out 8. I can remove 8, and I can remove 6 and 8. And then E,
Oh, this is a natural log.
yeah, we
Yeah.
haven't had E. I can take those out if you want as well. But E's in your calculator. I feel like you
Yeah.
folks can just find E. It's in your
Yeah.
calculator.
We did it last class.
Yeah,
We were
okay,
doing
okay,
natural
yeah, you're right, we did.
A little bit, but the way they showed it on the thing was a little bit different than we did it in class. Because you have to do like second ln and then do it,
Oh,
like when they,
Yeah.
when they do it on the
Yeah, yeah.
video.
mine's second Ellen. My calculator does that too.
Oh, okay.
3 decimal places. Yeah, that seems okay. Oh, and then I wanted you folks to realize that, we talked about this last class, right? Ln of E is just 1, so this is just 7. They undo each other. E to the ln of 7 is just 7, because these two parts undo each other.
Those are both 7? Or one's 1?
Yeah.
1, 7. Oh, they're both 7.
E to the ln of anything, that's just, all you have left is just what, they undo each other.
Oh, so that's square root of 2?
I'm sorry, what was that?
That's, C is square root
Yeah.
of 2? Okay.
And this one, what's the exponent for E? It's -5. Does that make sense? Because so this is really E to the -5, so that would be -5. Because 5 is down below. Because it's below, because you're dividing by, right? So it should be -5.
So it's just -5, not E -5?
Nope,
Okay,
because
just.
ln of E, that's like saying multiply, divide by. You multiply, divide by, and then you still get, all you're left with is this part here.
Okay.
Kind of, they undo each other. E and ln, and E to the power and ln undo each other. Yeah. And then just, yeah, growth and decay, I feel like that should be pretty straightforward. Right, and I wanted you folks to realize that which is this first one, is this linear, exponential, linear or exponential? So here's my
Oh, that's
exponent, or here's my variable. Is that linear or exponential?
Exponential.
Exponential, right, C times A to the X, kind of in a way. Right, this one here, this is linear. Everyone kind of see this one here?
Mhm.
Right, so then, kind of want you to kind of think about, this is exponential, because y, and is it increasing or decreasing? Is it going up or going down?
Yeah, increasing.
Yeah. Because this is larger than, my growth factor is larger than 1. Okay, so 6 and 8 I should delete. Six. Withdraw. Eight. Draw. Okay, there you go. Perfect. Was there anything in this one I wanted to do that too? Are these all okay? I think they were. I think I cleaned these up pretty well. So I went over those a couple of times. Yeah. Okay. All right, so run over those. I feel like you folks should be good on those. And let me stop the camera before it dies. Let's go ahead and take a look at our unit, our study guide. I think that would be the best use of our time. I want to have everybody take a minute and take a look through these. I feel like this one, the can of peas. We went over that pretty well last class, right? The unit rates.
Yeah, we did all 4 of those on the first one.
Yeah. Do you want to do number 3?
Sure.
We'll do 3A. How's it sound? Remember, if we're talking about unit price, that means the price per unit. So the money should be on top. Okay, so, what do we have? So we've got $1.29 for 15 ounces. So the price per ounce, 1.29 divided by 15, what did you all get?
0.86. Or 0.086, sorry.
0.86?
Yeah, 0.086.
Okay. And then for the other one, 2.39 for 26 ounces. 0.011,
9-1. 9-1.
91? Great. So you can see that this one is cheaper than that one, right? So which one's a better buy?
129 per 15.
Yeah. This one's a better buy. It's funny because like you always assume the large one's gonna be priced better, and that's not always the case.
Yeah.
Like wine, like you think like those big bottles of wine should be cheaper than the 750 mils of wine, and they're not.
Oh, yeah, no way.
Because I mean per ounce. Like you would think that 2 bottles of the 750 mil should be more expensive than 1 bottle of the 1.5 liters. A lot of times they're not because those bottles are harder to make, I think, or something like that. I don't know, but it's always throws in my thought. What's up with that? All right. I feel like we did that one already. So we'll take a look at this one again. So here, we've got some word problem. And so let's go through the possibilities. One, does it say, does everyone see the word direct or inverse there? Number 6, or did I take that one out?
Oh, no.
Oh, so skip that one?
Yeah.
Oh,
Is
sorry,
that a skip?
my bad. We'll skip that one. This one's okay. Is this one here, number 7?
Yeah.
Okay. So, does everyone see the word inverse or direct there? Inverse or direct? No?
So it's a linear?
You see linear?
No, I was just asking, if you don't see
Oh.
inverse or direct, is it linear?
No. Do you see the word exponentially or linear? No.
Doesn't say
So
anything.
then it's just a regular setting up a proportion,
Oh, proportion.
setting up a proportion one. So then you gotta figure out what are the 2 things that vary.
Inches and feet.
Yep, 1 inch goes with 4 feet. Everybody see that? And then they want you to find the length of wall. So the length of wall is same thing as feet. Oh, I'll be more clear. Represented by a line that's 1 3/4 inches long. So we have inches. We kind of have inches, and we have feet. And here this is inches. Does everyone kind of see that? Yes, no?
Oh,
So inches. And then we have feet. So this must be feet also. And I would tell you, find the length, I would say length in feet. If I do that, length in feet. It'll be clearer on the exam. Represented by a line. So what am I trying to find? I'm trying to find, where's my x? Where's my unknown?
The length.
Yeah, this one. That's my x that I'm trying to find. So make that your x. So then x over 1 3/4. So I'm going to put x over 1 3/4. You can put it in your calculator. If you put 3/4 in your calculator, and you get 0.75. So it's 1.75 equals. This is inches. this is feet. So I have to take the other point I have, and I have to put inches on the bottom and feet on the top. Does that make any sense for folks? So we know that these two go together, 1 inch and 4 feet. Feet have to be on the top, inches have to be on the bottom. And then that makes it really easy to solve, because I can just take both of these and I can multiply them by 1.75, so that these folks will cancel out. Or you put 1.75 over 1 if that makes you feel better. You can totally do that. Same thing. So then and then we'll know what x is. And the point is to get that part to cancel out. So everybody find x. X equals what? David, did you do it yet? Ryan, what'd you get? Alex, what'd you get?
I don't actually know.
So did you get the setup?
I got the setup.
Okay. So it's just a matter of multiplying.
And we got 7.
Okay, 7.
Sorry.
7 feet. Good? Great. Yeah, I think we wanted to do, I think we did I feel like we might have done 10 already, or did we do 10?
Yes,
Yeah.
we did 10 and 11.
Okay, good. We can do 12. Let's do 12. So 12, how can I factor, I only have 2 things. What can I factor out of these? Is there anything in common?
X.
X. So if I factor out an x, what am I left with? Everybody do it. Factor those.